Every year, millions of animals embark on incredible journeys across continents, driven by ancient instincts to find food.
From wild beasts thundering across African plains to monarch butterflies thousands of miles.
The question that has fascinated paleontologists for decades is whether dinosaurs, the dominant land animals for over 100.
For a long time, scientists could only speculate about dinosaur migration based on indirect evidence and comparisons with modern animals. However, groundbreaking discoveries over the past few decades have revealed compelling evidence that many dinosaur species were indeed long-distance travelers. The first clues came from unusual patterns in the fossil record, where certain dinosaur species appeared in locations far from where researchers noticed that some dinosaur fossils were concentrated in specific regions during certain geological periods, then seemingly vanished, only to appear elsewhere.
One of the most convincing pieces of evidence comes from fossilized trackways discovered in various locations around the world.
In places like Colorado and Alberta, paleontologists have found massive trackways showing hundreds of individual dinosaurs. These trackways reveal parallel footprints extending for kilometers, indicating coordinated group movement rather than random wandering.
The arrangement and spacing of these tracks suggest that different age groups traveled together.
This protective formation mirrors the behavior seen in modern migrating herds like caribou and
Analyzing the direction of these ancient pathways shows that many pointed toward areas that would have offered better resources during different seasons. Perhaps the most direct evidence comes from studying the chemistry preserved within dinosaur bones and teeth.
Scientists can analyze isotopes, particularly oxygen and strontium, which vary depending on the geographic.
These isotopic signatures act like chemical fingerprints, recording where a dinosaur spent different periods of its life.
This chemical evidence proves that these hadrosaurs traveled between vastly different climatic zones.
The discovery becomes even more significant when we consider that Alaska's position during the Cretaceous period placed it well within the Arctic Circle.
During winter months, this region would have experienced months of darkness and freezing temperatures, making survival incredibly difficult.
Migration would have been essential for these dinosaurs to escape harsh polar winters and access food sources that disappeared under snow and ice.
Large herbivorous dinosaurs like sauropods faced constant pressure to find sufficient vegetation to fuel their massive bodies. This enormous food requirement likely drove many sauropod herds to migrate seasonally, following the growth patterns of ancient vegetation.
Fossilized nesting sites provide additional compelling evidence for migratory behavior in certain dinosaur species.
These nesting grounds show evidence of repeated use over many years, suggesting that Maiasaura returned to the same location.
the concentration of nests in specific areas, far from where adult fossils are commonly found, indicates
Climate modeling of Cretaceous and Jurassic periods reveals dramatic seasonal variations in many regions where dinosaurs lived.
Carnivorous dinosaurs would have naturally followed their prey, creating entire migrating ecosystems moving across ancient landscapes.
young dinosaurs faced particular challenges during migration, and fossil evidence suggests different strategies for different species.
Some species, like certain sauropods, appear to have left their young in protected areas while adults migrated, returning periodically to feed them.
Other species, particularly hadrosaurs and ceratopsians, kept their young with the herd, as evidenced by mixed-age trackways.
The energy requirements for migration would have been substantial, requiring dinosaurs to build up fat reserves before undertaking long journeys.
Fossil analysis showing seasonal growth patterns in bones suggests many dinosaurs experienced periods of rapid sense days.
Modern technology, including high-resolution CT scanning and advanced optic analysis,
These ancient migrations likely shaped entire ecosystems, influencing plant distribution